Investigating spread. Spread is a description of the distribution or grouping of data in a given set. So here we are given two different dot plots. This first dot plot, the data is clustered closely together. And on the second plot, the data is more spread apart. So we would say that for dot plot 1, it is less variable, and dot plot 2 is more variable. Mean absolute deviation, or MAD as we'll call it, is a measure of the variability in a data set. The mean of the absolute values of the deviations from the mean for each data point in a data set. Calculating MAD. First, you'll find the mean of the data, and the mean is represented with the symbol X bar. Second, you'll find the deviation by subtracting the mean from each data point. Next, you'll find the absolute deviation by taking the absolute value of each difference. And then finally, you'll find the mean of the absolute deviations. Interpreting MAD. The MAD is the average distance between each data value and the mean. So if the MAD is large, the data is variable or spread apart. And if the MAD is small, the data is not variable or it's close together. Examples. Example 1. The number of ads sold by each of the 10 students on the yearbook staff is listed below. Calculate the mean absolute deviation, or MAD, for this data set. Okay, so we'll calculate the MAD by creating kind of a chart or table. So the first thing that I need for you to do is actually find your mean. So we're going to find the mean of this data set by adding all of these together and dividing by the number of values that there are, which is 10. So 1 plus 3 plus 3 plus 4 plus 6 plus 8 plus 8 plus 8 plus 9 plus 10. All of that divided by 10 is 6. So the mean for this data set is 6. Okay, so now we're going to go into creating our table. So the first thing in your table are your X values. So you're simply going to relist these X values going downward. 1, 3, 3, 4, 6, 8, 8, 8, 9, 10. Okay, so just list those values downward. Next, you're going to list your mean. Okay? Next, you're going to find the difference of the X and the X bar. So this is going to be X minus X bar. So we're going to be subtracting the mean from each of these data points. So 1 minus 6 is -5. 3 minus 6 is -3. 4 minus 6 is -2. 6 minus 6 is 0. 8 minus 6 is 2. 9 minus 6 is 3, and 10 minus 6 is 4. Next, we need to find the absolute value of our differences. So we're going to take each of these numbers and find the absolute value. Now, the absolute value is just the distance of that number away from 0 on the number line, which is always a positive value. So pretty much what we're doing is taking these negative numbers and turning them positive. So it's going to be 5, 3, 3, 2, 0, 2, 2, 2, 3, 4. All right. And lastly, we are simply going to find the average or mean of all of those numbers in our last column. So 5 plus 3 plus 3 plus 2 plus 0 plus 2 plus 2 plus 2 plus 3 plus 4 divided by 10 So our MAD equals 2.6. And it's as simple as that. So the best thing for you to do is just always set up a table that will help you to calculate your MAD. All right, example 2. The local library asked a random sample of patrons how many books each had borrowed last year. Find the MAD for the data, then describe the spread of the data. Okay, so we know that our first step is to find the mean. So 0 plus 3 plus 15 plus 22 plus 30 plus 61. Uh-oh, I missed my 50. Plus 50 plus 61 plus 75. All divided by 1, 2, 3, 4, 5, 6, 7, 8. Divided by 8. 32. So our mean for this data set is 32. Now let's go ahead and create our table. So first we're just going to list our x values. 0, 3, 15, 22, 30, 50, 61, 75. Next we're going to list our mean. 32, 32. Okay, next we're going to find the difference of the x value and the mean. So 0 minus 32 is negative 32. 3 minus 32 is negative 29. 15 minus 32 is negative 17. 22 minus 32 is negative 10. 30 minus 32 is negative 2. 50 minus 32 is 18. 61 minus 32 is 29. And 75 minus 32 is 43. Okay? And lastly, we need to find the absolute value of each of these differences. So 32, 29, 17, 10, 2, 18, 29, 43. And now we're just going to find the average of each of this last column. I'm sorry. So 32 plus 29 plus 17 plus 10 plus 2 plus 18 plus 29 plus 43. All divided by, I forgot how many it was. 1, 2, 3, 4, 5, 6, 7, 8. All divided by 8. So our MAD is 22.5. Okay? So now we have to describe the spread of the data. So basically we need to decide, is this MAD large compared to that mean, or is it small? So as I look at this, I would say that this MAD is large. I think 22 is pretty close to 32. So we would say because the MAD is large, the data is variable or spread apart. All right, let's go to example 3. Julie recorded the following as her grades for her first 6 French assignments. The mean for these data is 94, and the MAD is 3. But Julie forgot that because she turned in the first assignment 3 days late, her grade was marked down from 89 to 59. Calculate the mean and MAD for her actual grades, and compare and interpret the mean absolute deviation for the 2 sets. Okay, so before we can do anything, we need to go ahead and adjust her grades. So we remember that because she turned in that first assignment late, it's going to be marked down from an 89 to a 59. So now we need to calculate the mean and MAD for that. So the mean, 59 plus 90 plus 94 plus 94 plus 97 plus 100 divided by 6, 89. All right, now let's go to calculate the MAD. So first we're going to list our X values. 59, 90, 94, 94, 97. Oh, there we go. 97 and 100. And our mean, 89, 89. All right, let's go ahead and find our differences, our X minus our X bar. So 59 minus 89 is negative 30. 90 minus 89 is 1. 94 minus 89, 5. 97 minus 89 is 8. And 100 minus 89 is 11. Now to find our absolute values of those differences, 30, 1, 5, 5, 8, 11. Now just find the average of these numbers. So 30 plus 1 plus 5 plus 5 plus 8 plus 11, all divided by 6. So our MAD is 10. Okay, so now we need to talk about comparing. So we see that the MAD for the first set of data, and I'm just going to do green, the MAD for the first set of data is 3, and the MAD for the second set of data is 10. Okay? So this MAD is bigger than this MAD. The MAD for the second data set is bigger than the MAD for the first data set. So we can say that the second data set is more variable because it's larger, is more variable than the first data set. So let's think about why that is. So when we looked at our original grades, 89, well, what she thought her grades were, 89, 90, 94, 94, 97, 100. Those grades are all very close together. So it makes sense that if we were to put those on something like a dot plot, they will all be close together. But when we added in that 59, now we have a number that's set apart from all of the other numbers. And we could possibly call that an outlier. So it makes sense that now, because we've added in that really small number, that the data is going to be more spread apart. So we can say that the second data set is more variable than the first data set because of the outlier 59.